This is the y-axis, and here is the z-axis. One vertex of the tetrahedron is at the origin, and then 3, 0, 0, that puts us there. 0, 2, 0, that puts us here on the y-axis, and 0, 0, 1 puts us there. So these 4 points are the 4 vertices of the tetrahedron, and 3 of the edges are along the axes, and the other 3 edges are this edge in the xy plane, this edge here in the yz plane, and this edge here in the xz plane. So there's our tetrahedron. So the z variable is going to go from the floor at 0 up to the tetrahedron. So we have to figure out the plane at the top. And that plane, this is the point P here, this is the point Q, and this one is R. So that plane is created by the vectors PR and PQ. So the normal vector to the plane will be PQ cross PR. So let's calculate that normal vector and find the equation of this plane here at the top of the tetrahedron. So PQ, the vector from P to Q, we take the coordinates of Q and subtract the coordinates of P, and so PQ will be the vector -3, 2, 0, and PR, take the coordinates of R and subtract the coordinates of P, and we'll get -3, 0, 1. So then N is the cross product of these two. So to make the cross product, we'll make a 3 by 3 matrix with the vectors I, J, and K across the first row, and then PQ in the second row, and PR in the third row. And we will take the determinant of this 3 by 3 matrix. So this determinant is equal to the vector I times the determinant of this 2 by 2 matrix here, which is 2 times 1 minus 0 times 0, so that's 2. And then we want minus j times another determinant, so minus j times the determinant of the 2 by 2 matrix with those two and those two. Take away the j column and the j row, and you're left with those 4. So the determinant here is -3 times 1 minus 0 times -3, and that's -3. So here we have to put a -3, and that just makes this a plus. And then we have plus k. Now k is going to be multiplied by the determinant of, remove the k row and column, and we get this 2 by 2 matrix here. This was a -3, that's a 0. So -3 times 0 minus 2 times -3 is going to give us a positive 6. So this is the vector 2i plus 3j plus 6k, or 2, 3, 6. So that's the normal vector to the plane. So the plane is 2x plus 3y plus 6z equals some constant. And the point 0, 0, 1, for example, R, is in the plane. So if we put 0, 0, 1 here, we get the number 6. And we could have chosen any of these 3 points. P, Q, and R are all in the plane. So if we would have chosen P, 3, 0, 0, 3, 0, 0, we would get 6. And if we would have chosen Q, 0, 6, 0, we would get 6. So that helps us to verify that this is indeed the correct equation of the plane. Now, we need to solve this for z. So let's put that over here. So 6z is equal to 6 minus 2x minus 3y. So z is equal to, just divide by 6. I'll just leave it like that. I said 6, right? 6. Okay, so z is going to be between 0 and this fraction. Those are going to be our bounds in our triple integral for z. Now let's suppose we want to integrate dz, dy, dx. Z will go from 0 to whatever, to that number for any fixed y and z. And now let's figure out y. So for that, we'll have to look at the base of the tetrahedron that's in the xy plane. So the base of the tetrahedron in the xy plane, here's the x-axis, here's the y-axis. This is 3, that's the point P, and this is 2, that's the point Q. So this is the base of our tetrahedron in the xy plane. If we fix an x between 0 and 3, so x between 0 and 3, x is last, the outer integral. It looks like it's first, but we integrate from the inside out. So we'll integrate x last, 0 to 3, and y is going to go from 0 up to this line, from 0 up to whatever that line is. Y equals mx plus b. B is the y-intercept, so that's 2. So mx plus 2. And the slope, we go over 3 and down 2. So the slope is negative 3/2. No, negative 2/3. Negative 2/3, pardon me. Rise is negative 2, run is 3. So m is negative 2/3, and then x plus 2. So y is going to go from 0 to negative 2/3 x plus 2. So our triple integral is 0 to 3 for x, 0 to, let me give this thing a name, let me just call that star. We'll just keep an eye on that. And then z goes from 0 to, let's call this thing double star. And then we're integrating y, and we're integrating dz, dy, dx. These expressions are star and double star are a little bit clunky, so they don't fit up here very nicely. So I'll just give them these temporary names, but we'll recall the values of each of those symbols when we need them. So integrating dz, 0 to 3, 0 to 3, 0 to star, we get yz, and we have to plug in 0 and double star. So when we plug in 0, we get 0. When we plug in double star, we have to multiply that by y. So we'll distribute a y here. And we'll move this 6 on the bottom to the front. That seems convenient. Now distribute a y, and we get 6y minus 2xy minus 3y squared. And now we have to integrate dy dx. So when we integrate this dy, I don't like what's happening here. We're going to get a y cubed, and we're going to have to plug in star and cube it. So that doesn't look like any fun. I'm questioning the order here of the integration. Since this thing here is a y, that's going to cause the powers of y to be a little bit bigger than I'm comfortable with doing the algebra. So perhaps it would have been better to do this second integral, the second and third integrals in the opposite order. So let's just change the order of this right here, we still have this same integrand. I would much rather integrate this with respect to x, because then I would just get an x here and an x here and an x squared there. I wouldn't get any cubes. But here I'll get a cube and 2 squares if I integrate with respect to y. So let's switch that order of integration. So 1/6 double integral, same function. And now let's make it dx dy. But that means that our analysis here is, it's not that it's wrong, it's just that it needs to be modified. So instead of using these vertical slices in the base triangle with x and y, we'll need to use horizontal slices. So for a fixed y is between 0 and 2. So instead of x between 0 and 3, we have y is between 0 and 2. So 0 to 3 for x is going to change to 0 to 2 for y. And x is going to go from 0 to the line. And this line is in terms of x. So the line is y equals negative 2/3 x plus 2. We'll just solve it for x. So multiply both sides by 3. Don't forget to multiply the 2 by 3 as well. Subtract the 6. And then divide by negative 2. So x is negative 3/2 y plus 3. So we'll think of the line as having this equation. Well, it's the same equation, but change the form of the equation, and that goes here. And let's call that, for the sake of argument, triple star. We could probably fit it there. Yeah, let's just fit it there. That says negative 3/2 y plus 3. Okay. So it's good to be flexible when you're doing any math problem, really, but especially a complicated one. And here we have choices for the order of integration, so we'll take advantage of that. We had to backtrack a little bit, but it was relatively low level and quick, whereas if we had to cube the original star, that would be a little bit more cumbersome, even worse than what we just did. It would be nice if you're lucky and you just pick the right order the first time, but that takes quite a bit of foresight. I mean, maybe we could have had that foresight in this problem because we see that there's a y here, and so we might just figure that we're going to get these big powers of y. If it was an xy, we would be in the same boat no matter which way we went. And if it was an x, then I think we would prefer to integrate the way we did with y first. Okay, well, let's compute this iterated integral here now. We have back to blue. We have 1/6 integral 0 to 2. And now let's anti-differentiate with respect to x. It's 6xy minus x squared y minus 3xy squared. And x goes from 0 to, I'll write this as 3 minus 3/2 y. And then we have to, after we finish this, we have to integrate dy. So we have 1/6 integral 0 to 2. Quite a bit of algebra coming here. We have to plug this in for x. At least when we plug in 0 for x, we'll just get 0. So we just have to plug in the top value. So we're going to get 6 times 3 minus 3/2 y times y minus 3 minus 3/2 y quantity squared times y minus 3 times 3 minus 3/2 y times y squared. This algebra could be done as an aside, but I'll just do it inside of the integral. So distribute a 6y, that makes 18y. And distribute a 6y makes negative 9y squared. And then minus, here we have to square this guy first and then multiply by y. So let's put the y first and square this one. We'll get this one squared, which is 9, minus 2 times the coefficient times the coefficient. So that's the 2 here is going to cancel, and we're going to get minus 9y. And then plus, square this term, 9/4 y squared. And then distribute a 3y squared here, and we get minus 9y squared, and then plus 9/2 y cubed dy. Okay, I think we're almost done with the algebra here. Imagine if we had not changed the order of integration, it would have been even worse. So let's just gather all of the powers together. The cubes, we have a 9/2 y cubed. And here when we distribute this, we're going to get a minus 9/4 y cubed, and a half minus a fourth is a fourth. So we're going to get 9/4 y cubed. Now let's look at the squares. We have a square here. We'll have a square there, and we have a square there. This one's going to give us a plus 9y squared, and that one's a minus 9y squared. So those two will cancel, and we'll just get minus 9y squared. Now let's look at the y's. We have an 18y, and we have a minus 9y. So that's going to give us plus 9y dy. So finally we have, and there are no constants here, there's a y in every term. So we have a cubic polynomial integrated from 0 to 2. So this is a little bit of a piece of cake. We still have to be careful. It's easy to make an arithmetic mistake, but it's a basic integral. So we have 1/6, and then the antiderivative will have y to the 4th over 4. 4 times 4 being 16. We have 9y to the 4th over 16. And then here, y cubed over 3. 3's cancel. 3 cancels with 9. Minus 3y cubed. And here, 9y squared over 2. Okay, the antidifferentiation is done. Plug in the numbers. When you plug in 0, you'll get 0. Plug in 2, and we get an answer. 1/6 times 2 to the 4th is 16. Canceling the 16, giving us 9. That was nice. Minus 2 cubed is 8 times 3 is 24. Okay. Plus 2 squared is 4. Divided by 2 is 2. 2 times 9 is 18. And this is 27 for the two positives. Minus 24 is 3. 3 over 6 is a half. Whew. All right. The triple integral is a half. And I think the lesson from this problem is to prepare to be flexible. When you're doing a triple integral, the dv, you have some choices. So if one choice is seeming like things are a bit arduous, then maybe it's faster to do a little bit of work to change the order instead of doing a lot of work to continue with the inferior order. Okay, the answer was a half. Triple integral over a tetrahedron.